Hello guys, welcome to my channel. So today we'll be looking at a tutorial on how to use mobilenet from keras.application. So in my previous video I showed how to use mobilenet from Tensorflow Hub. In this case, we'll be using the same mobilenet from keras.application. So pretty much the first two steps are same as my previous videos, so I'll be skipping them, but I'll highlight the differences in this tutorial. So the height and width is the same, 224 by 224. In my three functions, the only difference is in read and decode. Instead of scaling the images now from 0 to 255 to 0 to 1, I'll be doing that step later, so we can remove this line. And then now we are going to load the classifier model from keras.applications, mobilenetv2, which will be ImageNet. We are going to train our own classifier layer, so include top will be false, input shape will be 224 by 224. Since we are not going to train any weights in the model, we are going to set it to false. So now for the dataset, I'll be using this cats and dog dataset for training with a batch of 10 images. The evaluation set will be batch of 1 image. So for the layers, we're going to start off with layers.lambda. So in lambda layer, we can pass in a function as well as the input shape. So the first function is we are going to use the preprocess underscore input function to cast the values from the data, which is 0 to 255 into 0 to 1. So this is the step which I deleted from read and decode. We'll be using it here now. We'll be doing the same step here now. And the next argument will be the input shape, which will be 224 by 224. And then we can add on the classifier model. And now for the embedding layer, we can have few hidden layers, but in this case I'm just going to have one. But before that, we will have to average pull the feature map from the model, and then we can add our embedding layer, followed by the output layer with one output and sigmod as the activation function. We are going to use Adam as the optimizer, binary cross entropy as the loss, and for metrics we are going to use binary accuracy. So now we are going to train the model for 5 epochs, and the hidden layer will have 256 neurons. So once we train and plot the validation and training accuracies, we can see that the model is doing very well with 0.97, and the loss is quite low as well. Thank you. Hope this is useful. Bye bye.